This video will teach you how to create models with lots of different parts. When we're making a model with lots of different features and parts, there are generally two ways to go about it. We can either add multiple sketches and extrusions within one model, or we can create individual models of the separate parts and then assemble the individual parts. Firstly, let's look at creating multiple parts in the same model. One way I can go about this is to build the assembly up part by part. See here, I've extruded a cube. Now, I select Sketch and select the face of the cube as the plane to sketch on. Here I'll draw a circle, enter my dimensions and finish the sketch. Now if I click Extrude and select the new sketch, it extrudes just like normal. The important difference now is that I have to consider the Boolean. A Boolean determines how two overlapping bodies interact. When you first select Extrude, NX will try to assume your intentions and select the most relevant Boolean. In this case, the software automatically selects Unite, as it assumes we want one solid body. Finishing the extrude, you can confirm this by hovering over the part. The whole part highlights red, as it is one solid body. If I go back into the extrude dialog by double-clicking it in the part navigator, I could change the Boolean to none. This would create the extrude as a separate solid body sat on the face of the cube. Again, to confirm this, we'll select OK, and hovering over the parts now shows them as independent bodies. Now let's go back into the extrude again, this time changing the Boolean to subtract. If you just hit OK, you'll see this error message. What this is basically saying is the subtract Boolean wants to remove material, but the extrusion isn't passing through any material to remove. So to change this, we'll go into the extrusion dialog and hit the reverse direction button found here in the direction drop-down. Now you can see the extrusion goes through the cube, and when we hit OK, you can see it has removed the material. Reopening the extrusion dialog once again, the intersect Boolean is basically the opposite of the subtract Boolean, in that it will keep any of the material where the extrusion is overlapping with the solid body, and delete everything else. Now we're going to look at assembling multiple parts in an assembly file. To prepare for this, I've created a few simple parts which, when assembled, will form a simple hinge. First things first, I'm going to create a new file, except now, instead of selecting Model, I'm going to click Assembly. Notice that even though I'm on Assembly, the file is still a part file, hence the .prt at the end of the file name. The main difference will be how I start working, how the tools are displayed in the ribbon, and how some layers of the model are named, but generally the files are the same. In an assembly file I can still sketch and extrude new parts, and in a model file I could still assemble existing parts. These loadouts are just there to aid you in your work. I'll name the part, select the save location, and click OK. Now you'll notice, because we're in an assembly file, the Add Component dialog automatically appears as soon as we start. If I had open parts in the background, or if I had recently used parts in this or another assembly, they would appear in this file navigator. As it's empty for now, I'll open a file from the browser down here. The browser automatically opens to the file your assembly is set to save into, so making sure you've selected the right save location is super helpful. I'll start by loading in the hinge example part, and for the first part we're just going to position it using the absolute origin. Now, what you're essentially doing when assembling a model is constraining multiple parts to each other, and just like when we were constraining a sketch, the easiest way of doing that is to first move the parts to roughly where they need to be. So we'll start by going up to the Assemblies ribbon and selecting Add Component. This comes up with the same options dialog we saw at the start, so I'll go back into the file and select the two parts I need by holding down the Control key. So for these parts, on the positioning option we're going to select Move. Now when I click OK, I get another options dialog allowing me to specify an origin for the placement of the new parts. I'll put 30 in the X direction so that when they're placed, they won't overlap with the current hinge. I'll hit OK here, and you'll see the two parts have appeared in the assembly window. Now, it automatically gives me the Move Component dialog, so I can move these new parts about. However, as I added them at the same time, it wishes to move them together, and I need to move them independently. So I'll just hit OK here, and now I want to hit Move Component up here. I'll start by selecting the second hinge housing, then click Specify Orientation, and I'll rotate it 180 degrees about the Z-axis. Now I want to rotate the pin, so I'll select it. Okay, now see that the hinge housing has moved to where I clicked, because I was still on the Specify Orientation mode. I'll hit Ctrl Z to undo the action. Now I'll go back to Select Components. I want to deselect the housing by holding down Shift while clicking, and then I click on the pin to select it. I'll rotate that 90 degrees as shown in the dialog box next to the cursor. Then I'm just going to move it back slightly and lift it to be roughly in line with the housings. And hit OK when I'm happy. Now to constrain the parts, I'm going to select the Assembly Constraints button up here, and this will open the Constraints dialog. Just like with our sketch constraints, you'll see I have a range of options for how to constrain my part. There's touch align, concentric circles, setting a distance between parts, making parts parallel or perpendicular, and so on. The most common choice would definitely be the touch align option, and that's because within it you've actually got multiple options of touch, align, and infer center axis. Now there are a number of ways that I could go about aligning these components to produce the same results. However, the best way to choose is to think about what joints and forces would actually be involved in the real product. I know that this is a hinge, so I want the two housing parts to be able to rotate about the pin. This means I don't want to align the faces of the hinge, as that will fix them to be 180 degrees from each other. I can use the Infer Center Axis tool to center the housings on the pin like so. And then align this end face of the pin with the end of the housing. This all looks good, everything's in the right place. Now if I click OK and go back to move the housing, you'll see that moving it in the X or Z direction moves everything, and rotating about the Y axis opens and closes the hinge. However, if I move in the Y direction, or rotate about the Z axis, then you'll see that the other housing is actually moving up and down the pin, which we don't want. This just shows that even though your model parts may well look like they're in the right position, you still want to constrain them fully so that nothing moves later on when you don't want it to. So to fix this, I need to cancel the move. Do you want to discard changes? Yes, I do. Now I go back into constrain, and I add an alignment constraint between the end face of the pin and the end face of the other housing, and they become fixed. I'll click OK, go back into move, and now you'll see that the only moves I can do are to move everything and open and close the hinge. Now there's actually one way I could have done this with fewer constraints, so I'll undo all of these. Now if I go to constrain it now, I'm going to add a concentric constraint between the ends of the pin and each housing. One at this end, and then one down here. The concentric constraint essentially applies both the inferred central axis and the alignment constraints in one go. So up here, it's given the pin and the hole a shared central axis, and it's aligned the pin end face to this face of the housing. Now with just these two constraints, if I go back to move the components, you'll see again that I can either move everything or open and close the hinge. Perfect. Now you're able to create a fully assembled and constrained model. We can do all sorts of things, such as turn it into an engineering drawing, run it through finite element analysis or another analysis plugin, or render the model for high quality images that you can then use in coursework, posters and advertisements.